Uh, Understanding blockchains. So this is the first in a talk series about understanding blockchain technology. I am focusing on the technology aspects mostly, and not the other things. But before I get started, what I would like to do is talk a little bit about myself, so that you have an understanding of who I am and why it makes sense to listen to me. Uh, I do have, basically, I am a computer science tech geek. I have an understanding of the technology. I've been in this space for over 25 years. Last 10 years, I have also been helping a bunch of fintech companies with finance stuff. I have not myself worked with blockchain directly, but in recent, about the last 4 years, I've been tracking this technology, not just Bitcoin itself, but the whole ecosystem. So I do have some understanding there. Uh, Plus, I think I'm pretty good at explaining it to people who don't understand anything. So I think of myself as a 10-year-old explaining things to 5-year-olds in this area. Okay, so before we get started on the details, what let me give a little bit of context. I know all of you are here mainly because of Bitcoin, right? That is what you're really interested in. What is Bitcoin? It's a cryptocurrency, which is a currency that is not backed by any government, that is not backed by any big company, and yet it is a currency that has a $300 billion market cap. It is something that uses blockchain technology to do this. So we need to understand what is a blockchain. A blockchain is essentially a way of managing transactions, keeping track of transactions without any centralized database, without a government, without any company. So, without the need to trust anybody, you can have a system where you can keep track of transactions in a way that they cannot be deleted and they cannot be modified. So that is what a blockchain is, and that is what I'm going to explain today, right? So here is the quick thing. To understand Bitcoin, you need to understand what is cryptocurrency. To understand cryptocurrency, you need to understand what is blockchain. And to understand blockchain, you need to understand why does it exist in the first place? What is the problem blockchain is solving? In today's talk, that's what we are going to do. I am going to take one sample application, home ownership, as an application that currently is being solved using a combination of online and offline technologies, and then show what would need to be done to flip it over entirely to be a digital solution. And then, while we are doing that, what's going to happen is that we will keep it running into various problems, and we will solve each of those problems. And by the end of the talk, when all the problems have been solved with our home ownership application, what you will realize is that we have built a blockchain. Okay, so I'm just going to take a quick pause here to see if there are any technical issues or any problem. Um, Let me see. There is a
Naveen, Abhay is online. He can hear you, but he
yeah.
can't see the chat and we can't hear him. And
Okay,
Matin is on.
say that again.
Abhay Patil is online. Uh, can't see. He can't. You can't hear him apparently.
Yeah. Okay.
And
No, so that's okay. People other than Bhushan Shukla, Anurag Chaturvedi, and Abhay, I can't hear anybody. And unfortunately, I can't even see your questions. So I am going to rely on these three guys who are online with me to ask me the questions. And if you have any questions and you manage to send it to them on WhatsApp, they will be able to ask the questions. Okay. Um, Any other issues, Bhushan? I think there is a issue that whenever there is some noise on your side, the screen flips over to you. So stay on mute until you have a question. All right. So I'm going to assume all is good. I'm going to go ahead. Uh, we are going to start talking about the technology. Why do we need a blockchain? So we are going to go in reverse now, starting with the bottom. Uh, Blockchain, there is no Bitcoin, no altcoin today. So if you're expecting that, that's not the day. But hopefully, the next talk we are going to talk about Bitcoin, and then there is a whole series that I have planned for the other parts of the blockchain ecosystem that would be good to understand. But those are later. Um, Today, we are only going to talk about land records, and we want to digitize this system entirely. So, the running example I will use is that Julie, who is the current owner of house number 42, wants to sell it to Neha. Okay, and to do this, the way it happens currently is that Julie and Neha sign an agreement where Julie says that house number 42, which is currently owned by me, is now going to become the property of Neha. And in return, Neha gives a bunch of money to Julie. This is how it happens. Now, this has some potential problems, and we need to prevent those problems. First of all, how does Neha know that the house number 42 is owned by Julie? That needs to be confirmed. Somebody else could be selling it to her. Or house number 42 is owned by Julie, but the seller who is sitting in front of Neha and taking her money might not be Julie. These are the problems at the time of the transaction. Other problems can happen later. So, for example, 3 years later, Julie says, "Hey, I never sold it. That transaction never happened." Or Julie says, "Yeah, yeah, well, we did have a transaction, but that was house number 43, the one in the back, the ugly one, not house number 42." Right? These are the potential problems, and I will just talk quickly about the current system and how it solves these problems. Right now, what we do is when we sell a property, we make an agreement and we register the agreement with the government. Right now, all agreements are supposed to be registered with the government. So if you want to find out the current owner of house number 42, you just search through that registry, find the last transaction involving house number 42, and see who was the new owner according to that agreement. And as long as it is Julie, you are good. You know that Julie is the current owner. As far as the person who is in front of you, is that Julie? You look at their license, you look at the photo there, you make them sign, and you compare the signature with what's there on the ID card. After you have signed the agreement, this new agreement you'll go and register with the government. And at that time, also government officials will notarize that entire agreement. They will say, yes, this agreement was signed in front of us by these people, and we checked their ID and all of that, right? And finally, the other thing you want to prevent is that the details of the transaction, we don't want changes. So for that, the current system is that both the uh, co-parties, they initial each page of the agreement, and you have hard copies printed. And in case of a dispute, you produce one of those copies to say that, see, you can't change things. Okay. The thing is that this system works, but not very well. We all hate the registrar's office. It is a bottleneck. It takes time. People need to be present in person. So it's an issue, right? Can we do better? Can we get rid of the central government bottleneck through the use of technology? That is what we are going to solve for the next half an hour or so, right? And for that, I mean, the idea is fairly simple. We have a simply an online database of property owners. Okay. And that database keeps track of who's the current owner and of all the transactions. The problems that I talked about earlier. Who's the current owner of the property? Is this person really that's the same person? And are the transactions permanent? We are now going to look at whether our online database has solutions for these problems. Okay. To solve these problems, basically, we are going to use digital authentication, and I will explain what that means as I go ahead. Okay. So at this point, I'm just going to pause and see if there are any questions. At this point, you should have understood the problem. I have not yet talked about the solution, but are there any questions related to the problem? All right. Okay. So looks like we are good. I'm going to go ahead. So our simple solution is that Abhay has a web server on which he has a database of house owners. Every house owner has been given an account and a password. That password is only known to that homeowner. And then the web server ensures that only the current owner of a particular property can transfer ownership. So that owner needs to log into the web server, that owner needs to use the password, and only then they can transfer ownership, right? This, as long as Abhay has ensured that every owner has a unique password and they don't share it with anybody else, this will work. Okay. Um, in this web server, I mean, one of the good things we know in life is that you should have an audit trail. So we don't just record the current owner, we keep a record of all the transactions. By the way, such a record of transactions is called a ledger. And that is why whenever people are talking about blockchain, you will keep hearing the word distributed ledger. So this simple idea of recording all the transactions in a book, one after the other chronologically, is called a ledger. And if you manage to put it online without requiring a central server, then you have implemented a distributed ledger. Okay. And the reason we are all here today is because 10 years ago, Bitcoin was implemented using a distributed ledger. And that is the first time in history that somebody had implemented a distributed ledger without requiring a central authority. Okay. So onto our ledger. Right now, Abhay's web server is a ledger, but it is not a distributed ledger. This is what the ledger looks like, right? And in this, I just want you to note house number 42. It has multiple entries. So in 2000, somebody sold the house to Julie. And then in 2006, Julie sold the house to Neha. Now, the assumption is that in 2006, when Julie transferred the house to Neha, Julie had to log in using her account. And that is why she was able to do it. Once she has transferred it to Neha, now Julie logging in, she won't be able to even see house number 42. She can't transfer house number 42 because Neha is the new owner and Neha needs to log in if she needs to transfer house number 42 to anybody else. Okay. So that these are the ones I was talking about. Let's go on to the problems. This is not really a full solution. First biggest problem is that Abhay, who is the owner of this website, can do whatever he wants. He has full access to the database. And knowing Abhay, we can't be sure. He can insert fake transactions. He can put whatever he wants. And we need a solution for that. So basically involves digital signatures. I am not going to explain right now what a digital signature is. That if we have time, I will do in the end. But for now, assume that a digital signature is something like a password, but stronger. And when a person signs a document using a digital signature, there is a guarantee that nobody else could have done it. Okay, it's just like a signature, real signature, but it is digital. So now what we do is that we modified our database, which is still stored on Abhay's server, but with every transaction, we have included a digital signature. And what the digital signature guarantees is that uh, this particular transaction was signed by the owner of that property. Okay. Now, I just want you to note that the digital signature, unlike our real life signature, which is the same signature everywhere, the digital signature is unique for any given transaction. So the same person signing two different transactions will end up with two different digital signatures. Okay. So this will become important later on. The only thing you have to remember is this, that only the owner can sign, and the signature depends on the transaction details. So if you change any of the transaction details, the signature becomes invalid. So that ensures that now Abhay or anybody else, in fact, can no longer fake a transaction. They can't even change the details of a transaction that has been created, because change anything and the signature no longer matches, and now it can only be updated by the current owner, right? The bad news is that Abhay can still delete a transaction, and this can cause problems. Let me just take a quick example, right? So in 2006, Julie sold house number 42 to Neha. Now Abhay deleted this transaction. So now a little while later, what Julie does is goes and finds another person called Repeater, and tells him, okay, I own house number 42 and I can sell it to you. Okay. Now Repeater goes and looks at the database. Now, because the Neha transaction has been deleted, to the new person, it looks like the current owner is Julie. So this guy is okay, he's happy with doing this. Remember that Julie can't log in to the system and change the ownership, because now it is owned by Neha. But Abhay can still do this. Abhay can go into the system, he can add a new transaction from Julie to Repeater, and it is signed by Julie. So it will look like Julie sold this house to Repeater, and now either Neha or Repeater, one of them is in trouble, right? This is what we want to prevent. Have we understood the problem? This is the key problem that blockchain solves. So I'm going to pause here to see if there are any questions about the overall situation so far and what is the problem we are trying to solve. Okay, so looks like there are no questions. I am going to go forward. What we have done is that we have used digital signatures to ensure that our problem of who's the current owner and authenticating the current owner, and not being able to modify transactions, those are solved. Now the only problem we have to solve is the problem of the website owner being able to delete transactions. Okay. The solution is again relatively simple. We can't trust Abhay, so we need multiple people to keep him honest. So we create multiple servers. All of them have a copy of the same database, the same set of transactions, the same ledger basically, right? And we already saw earlier that the owners of the servers, they can't modify or delete transactions. The only thing they're ever allowed to do is add transactions to the end of the ledger. Now Julie and can't go to Abhay or any one single server and collude with that person to be able to delete a transaction and do a double spend. Okay. Because anyone can go to other servers and show, see, there is a transaction there and it was actually signed by Julie, and prove that the transaction happened. So as long as you can keep the multiple servers in sync, the problem is solved. Come to the real problem now, which is how many servers is enough, who decides which servers will be doing this, and over time, as the system gets popular, can we add or remove servers? Some server dies. All of these are tricky problems, right? Blockchain is the first solution that comes up with a system where you can have any number of servers, anybody can join at any time, and let supply and demand solve this problem. because any other way of solving this problem would require a central authority who is in charge of deciding number of servers or deciding who gets to join as a server, right? So now we are getting into the meat of the blockchain, which is that if there are any number of servers and anybody can join at any time, how do we keep everybody in sync? Okay, this is the core problem now, which is that the data needs to be kept consistent across the servers. Now, the database industry has been dealing with such problems for a very long time. You must have heard of terms like distributed transactions and paxos and so on, right? And there are standard solutions that databases had to this, but they don't work. Most of the distributed transaction solutions don't work because they require you to know upfront how many servers there are. And the other simple solution is that databases have is to designate one of the servers as the master. All updates first go to the master server, and then the master server forwards everything to all the other servers, which are called slaves. Now, this would work really well. It is excellent at keeping things in sync. The problem is that it doesn't solve our problem at all, because whichever server is the master is now somebody who can change the database and who can, Julie can bribe that one person and double spend the house, right? So it's still basically centralized and it is back to square one. So we need a different solution. And the blockchain solution is to have a rotating random master. So the idea is that if you as a user you want to submit a transaction to the system, you can submit it to any server. The servers accept the transaction, but they tell you, hey, hold on, this is a temporary accept. I have not yet confirmed the transaction. Give me a few minutes to figure things out. Okay. So for 10 minutes, all servers keep accepting transactions, and every transaction that they accept, the unconfirmed ones, they forward it to all other servers in the system. Okay. At the end of 10 minutes, there will be maybe say 200 transactions that have accumulated. At that time, a random number generator is used, and from all the servers that are live right now, one random server is picked and said, okay, you are the master right now. You create all the transactions. So what does this master do? It takes all these 200 transactions that are unconfirmed, that were submitted in the last 10 minutes, creates one block of those transactions and adds this entire block to the database, and then forwards this block to everybody else saying, hey, this is the new set of transactions. This is the update that has been made, and everybody adds that to their database, and this whole process restarts. Okay. So I'm going to pause here. You guys, you need to ask me questions. Okay. So one question is that can you repeat the problem? Okay. What is the fundamental problem that we are trying to solve? The fundamental problem that is that you want to update transactions into a database, but you don't trust anybody, right? Any one person that you trust, any one person that you use for updating the transactions could be corrupt or could be corrupted by the seller if the stakes are high enough. And if that person can change the transactions, then you are in trouble, right? In fact, let me go back a few slides and look at the deleted transaction situation, right? So I have a ledger of homeowners, and here what happens is that because every transaction needs to be signed by the current owner, you can't easily fake a transaction, right? Now, the only thing is that if somebody is now at this point selling house number 42, right, you have to check who's the current owner of house 42. Right now, what you see on the screen, if you read through that, you will know that Neha is the owner of house number 42. Okay. Now, neither Julie nor Abhay can really change that fact. Okay. What they can do though is that if this transaction is deleted entirely, okay, now a person who is trying to buy house number 42 will think that Julie is the owner and will be happy to get a transaction signed by Julie. Without that, if the database showed that Neha is the current owner, then Julie wouldn't be able to create a transaction because this person won't trust Julie. It needs Neha's signature, correct? But without this transaction, nobody knows that Neha has is the current owner. So somebody will accept the house using Julie's signature, correct? So that is why what we need is a solution in which nobody can delete transactions, including the website owner. Okay. Uh, by the way, so Bhushan and Anurag, it is not easy for me to check the text every time. So you two guys, you should ask questions audibly. Okay, when I say are there questions. So
Naveen, there are no questions at my end just now.
I'm reading Abhay's questions. Okay, let me take a quick look at those. Uh, there are questions related to who owns these servers and what are the minimum specs and so on. I will come to those a little later. But uh, main question was about what happens when are there conflicts. So we are going to spend a lot of time with conflicts. Okay, but at this point, what I want you to be clear on is that fundamentally right now the main thing we're trying to prevent is a one server unilaterally should not be able to delete a transaction. And what we have done is that we have said that your transaction will go on multiple servers, and only when a majority of them have accepted it, that's when the transaction is considered confirmed. And then after that point, no single server can delete it because the transaction exists on so many servers. And if you wanted to get rid of the transaction, you would have to go and convince a majority of those servers to delete the transaction, which is of course considered far more difficult than convincing just Abhay. Right. So any questions regarding that particular issue, which is that once the transaction is on multiple servers, then we are good. So now the only problem that is left to solve. Yeah, Anurag, go ahead.
Uh, Question is, how do you access this network of servers?
Okay, question is how do you access this network of servers? So this is, I don't know if you remember P2P servers from the Napster days. So there is just, people keep updating lists of servers which are live on the blockchain network, and you can find lists anywhere. Or if you understand the blockchain protocol at the lower level, then you can just run a little program which will start sniffing on the network to see which servers are alive and nearby and so on. So that's not a particularly difficult problem. For now, assume that there is some sort of a simple algorithm which can find whichever servers happen to be live right now, right? Question that has come up is, can the majority of servers get the wrong information, and is it possible for the majority to accept wrong information? So here, think of it this way. Okay, now if Julie is selling a plot to Neha, right, all the server needs to confirm is that Julie is the current owner, which means that it needs to go back into history and look at all transactions involving house number 42 and see what was the last one. And as long as the new owner on the last transaction is signing the next transaction, there is no real danger of wrong information. The only wrong information, danger of wrong information, is that if there is an unconfirmed transaction, at the same moment, Julie is trying to sell this house to two different people and submits one of those transactions to one server and another transaction to another server, then you do have a problem, right? But we will talk about that a little later. There are solutions to that. This issue of in the last few minutes there being conflicting transactions for the same thing, there is no real problem because everything else is the digital signature and an immutable record of previous transactions is good enough. Any other questions so far? Okay, I'm going to go back and continue. Let me just explain the idea of how blocks are formed and how servers accept transactions, right? So you might not see all the details on the screen right now, but just I want you to understand that the nice table with a background, those are the confirmed transaction. That is the previous block, right? And then below that, for the next 10 minutes, servers are accepting new unconfirmed transactions. Those are the things at the bottom. And you can see that although most of the unconfirmed transactions that server 1 and server 2 see, they're mostly same, but one last transaction server 1 has seen and server 2 hasn't seen. My point is that there can be small discrepancies between the set of unconfirmed transactions that different servers have seen at any given time. Okay. Now, what happens is that at the end of 10 minutes, there is a random choice of server as to who's going to be the master. And in this case, let's say server 1 got picked to be the new master. Now, server 1 has these 5 unconfirmed transactions that it knows about. It says, okay, I am now creating a new block using these transactions that has been made into a block. Now, this information is sent to server 2 and all other servers, of course. And those servers, what they do is they delete all the unconfirmed transactions that they know about, which are already included in this new block, and instead replace that information with this new block. This new block gets added to the ledger, and now the whole process repeats. Just one thing I want to clarify here is that at this point, if there was an unconfirmed transaction that server 2 knew about, but server 1 didn't know about it, so obviously that transaction is not included in this new block that get created. So what server 2 does is that one transaction it will keep around. It will remove all the others because they have already been added into the last block that was committed, right? So those are deleted, and the one transaction which is not there in the confirmed set, server 2 will keep it around, and in the next round hopefully that gets included. Okay, so let me check for any questions.
Naveen, Matin,
Yeah, go ahead.
question. He's asking, what if the
Yeah.
majority of servers go down or get hacked?
Yeah, so great question. If a majority of the servers go down and get hacked, there is nothing you can do. There is no solution to that problem, and that is not a problem we are trying to solve. We are going by the assumption that most of the servers are up and they remain honest or unhacked, right? So this is a solution to the problem where most of the servers only a minority of the servers can get hacked or corrupted at any given time. Okay. All right. Someone on WhatsApp is asking a question. If that comes up in the next few seconds, I will answer it. Otherwise, I'll answer it a little later. If you have any questions, please keep sending them. Let me go back to the presentation. All right. So
Naveen, hang on.
Blocks.
Naveen, there is a question here by Abhay. He's asking, the Jasmine transaction is only on server 1, but it is accepted. Isn't that unfair?
Yeah. No, it is not. So the question was, there is a transaction that was accepted on just one server, and still it got accepted. See, the point isn't that blockchain in general does not take any position on if there are two conflicting transactions, which one is the correct one, right? Let's say house number 32, which is being sold to Jasmine right now on server 1, right? At that exact same moment, the same owner is trying to sell house number 32 to Bhushan also, right? Now, note one thing. Only the original owner can be originating both of these transactions, because the transaction needs the signature of the original owner. So a third party can't be doing this, right? So the original owner is trying to create two different transactions. The blockchain says, you know what, let that person do what they want. I'm going to randomly pick any one of them, confirm that, and then the system will ensure that the second transaction does not get confirmed, right? So from two conflicting transactions, the blockchain knows for sure that the original owner initiated both the transactions, and the blockchain doesn't care. The blockchain just says that my job is to ensure that only one of these gets accepted, that two of them shouldn't get accepted. Okay. Now, how is information shared by many servers to the seller, right? The seller doesn't need to worry about it. The seller just has to submit the transaction to any one server, and then that server will forward the information to all other servers. In later talks, we will see that there are incentives in place to ensure that servers will try to forward the transaction to as many servers as possible. There is no point in trying to hide the transactions, right? And second is, you again don't need to worry about two different transactions coming at the same time. Usually that doesn't happen unless one person is trying to double spend. That's the only way you can get two conflicting transactions, and that is handled by the system. Okay, so let me continue now. What is a block? Okay, a block is one block of transactions which is added to the system every 10 minutes. Each block contains an ID, right? One identifier for that block, which is unique for all time. Just basically, it's a random number. But when a block is created, in that it embeds the ID of the previous block. I mean, by previous block, I mean the latest, most recent valid block that this server is aware of. Okay, and then that ID is included, plus then all the new transactions that need to be confirmed, and then this entire block is signed by the server digitally, okay, saying that I guarantee that these are the transactions and so on. Now this ID of the previous block that you are including, right, that is the cool part, which is that if you send this block to a whole bunch of servers and one of them had a network outage because of which they missed some messages, all they can do is that they check what is the previous ID and do they already have that block. If that server was missing the previous ID, then it knows something is wrong, and it can send messages to the other servers saying, hey, looks like I'm missing some information, send me the whatever blocks you have, and then it can get in sync. This IDs which are chained all the way backwards, right? This ensures that things are kept in sync. So whenever you get any information, you can verify it all the way backwards to make sure that you're not missing any information. So we have transactions in blocks and we have chained them together. Okay. Now, at this point, I'm going to pause. The one big problem we haven't solved is I just sort of glossed over it. I said, oh, our server is picked randomly. We don't know how to pick a random server because we don't have a central authority and we don't know the total number of servers, right? You guys, somebody should have asked me that question, that how does that happen? That's the whole point. That's the problem we're going to solve. But so we are going to look at that right now, but I will ask. Okay, so the question is that are only blocks allowed to delete transactions? Okay, think of it this way. A transaction that is unconfirmed is not really considered a real transaction. Okay, so if it is just one of the unconfirmed transactions floating around from the last 10 minutes, it's not a real transaction. So anybody is allowed to delete it. A server which is creating a new block can choose not to accept that any transaction that it wants. Sometimes it will do so because it has already accepted a conflicting transaction. That is rare. More often, the server might just say, I don't like you. Server is okay with that, right? Basically, in the Bitcoin talk, we will see that for every transaction, you have to give a commission to servers, okay, commissions and other incentives. And if this particular server doesn't like how much commission you are paying, the server will not accept it. And then you have to resubmit the transaction with a higher commission and things like that. Don't worry about that. That is not something to worry about for today. That is for next session. Okay.
Naveen, there is one more.
Any other question? Yeah, Bhushan, go ahead.
Yeah, Abhay is asking, so do all the servers have to have all the blocks all the time?
Absolutely. So this is a great question. Every server has every block, every transaction all the time, right? Which means that if there are 100,000 servers in the blockchain system right now, all 100,000 of them have an entire copy of the entire database, and the validations that need to be done, which is checking if the signature matches and checking if this happened, all of that, right? That is being done by all the transactions. So this is an expensive way to hate the government. Okay, so do not ask any questions about efficiency right now, at least. In later sessions we can look at that, but right now efficiency is not the point of the system. We are giving up a huge amount of efficiency to get something else in return, which is social scalability, being able to do something without requiring a government. Okay, let me continue. So now I think we have pretty much solved all our problems except for the fact that we don't know how to pick a random server in a way that cannot be hacked. Because if upfront you knew who's going to be the random server for the next one, there could still be an issue. Or if the randomness itself could be hacked, so that every time only servers that are your friends get selected, then the system can still be hacked. So how do we choose randomly? And that is the clever part of blockchain, right? To be able to choose a random server without requiring a central authority, what the network does is that make everyone solve a hard math problem. It is really hard. It takes a long time. On the best CPUs, it is going to take 10 minutes to solve that, right? And the first server to solve the problem becomes the master. They are the server that is able to create the new block, and nobody else can do that. And to prove that you have solved the math problem, you have to show the solution. Everybody can validate the solution, but finding the solution is hard. Validating it is easy, right? So, and because the problem is a random problem, you don't know which server will be able to solve it and at what time. Okay, I'm going to go a little bit into the maths detail of this problem, because I think understanding that problem makes it very clear how this whole system works, right? So at any given moment, a server which wants to become the current master. And why should the server want to become the current master? Because whoever is the current master, whoever added a new block to the system, usually gets an incentive in the form of a mining reward. Okay, so that's something we will discuss next time. But for now, assume that server wants to become create the new block. And to do that, what you have to do is solve this problem, which is, you know, the contents of this current block. You have to compute some function whose result, whose value is based on the contents of the current block. It is like, doing a compressed encryption of the block contents. This is called a hash. So technical guys, this is basically just hashing, right? One-way hashing. Now, hash is easy to compute. The thing is that if you modify any character in a block, the value of the hash changes completely. Okay, and I'm going to talk about that right now. Okay, but what you have to understand about the hash is that the value of the hash depends on the contents of the block. If you change anything, the hash changes completely. It is easy to compute the hash, easy to verify that a hash is correct, but it is impossible to reverse engineer. It is not possible to create a block whose hash matches a given hash. Okay, so I know it is a little complicated, so I'm going to take an example. Imagine that what you are seeing on the screen right now is one particular block, right? It has a block ID, it has the ID of the previous block, and I am shown only 2 transactions. In reality, there'll be about 150 to 200 transactions. Okay, now this random text at the bottom, that is just a part of the blockchain protocol, which is that in any block, you are allowed to put some random text. Why will become clear in a minute, but you are allowed to put some random text, and the server which is creating this block can put whatever they want here. Okay, and now if I compute the hash of this block, I will get some particular value. Now these contents, including the random text, if this is the content, the hash will always be like this. The hash cannot change. The hash is a fixed value. Okay, but what I can do is I can change the random text and the hash changes completely. Okay, so the real contents of the block, transactions and the IDs, those obviously you cannot and you don't want to change those, but you keep modifying the random text. You can see that I'm just making a small changes to the random text, and as I keep modifying them, the hash value keeps changing. And what I am supposed to do is to keep doing this, keep changing the random text until I find a hash value that ends in 4 zeros. Okay, so I keep doing this. So I'm on sixth try. On the 7th try, I got something. This hash value ends in 4 zeros, and I say, yes, I got it. I am the master. And this entire block with this random text, I send it off to everybody. Now, what does everybody do? They look at the block, they compute the hash, and they see, oh yeah, it does end in 4 zeros. So they know that this server has solved the problem. Okay. Now, in reality, it is not 4 zeros. It is the number of zeros is something that changes over time to ensure that no matter how many servers are there in the network, on an average, it is going to take roughly 10 minutes to find the next hash. Okay, so maybe it will be something like it needs to end in 35 zeros. So as of last month, in Bitcoin network, if you wanted to find the correct hash for a new block, it required so many computations. I think that is 16 petabytes or something like that. 16, a huge number of computations, and all servers are doing this all at the same time. And then randomly one server gets lucky. It's a lottery. The server which wins the lottery ends up with a hash that ends with the appropriate number of zeros, and then that block is created, right? So I am going to pause here and check if there are any questions regarding creation of the block, because this is it. This is the full solution. And after this, I'm just going to talk about how we handle conflicts and answer questions. Okay, so let me see.
The questions about efficiency won't be taken right now, isn't it, Naveen?
Let us not. If there are any other questions, okay. There was something about competition about blockchains. That is a good question. I will take that later that will come in like one of the later talks. Okay, let's understand a single blockchain. Any other questions about how a random server is selected? Yeah, go ahead.
Yeah, there is a question by Abhay. It says this hash value changing can be an indeterminate problem, or is it completely random operation?
Yeah. No, can you repeat the question?
Yeah, the question is this hash value changing can be an indeterminate problem.
Yeah.
Or is it a completely random operation?
Yeah. No, so the thing is that the algorithm used for computing the hash of a block, that is fixed for all time. When the Bitcoin network was created, Satoshi said that this is the function we will be using for computing the hash. The number of zeros that are needed, that is something that gets updated every week. Okay, and later on, if there is time, we can get into that. But other than that, the computation is exactly fixed. Given a block and the random text, there is only one way to compute the hash. There is no randomization there, right? The only randomization is in what random text you put at the bottom. But once you fix that text, the hash value is fixed. So the only problem is that you have to try large number of random text in your contents to make the hash come out. And there is, the mathematicians have spent 50 years proving that there is no other way to do this, no other way to get appropriate hash value except to just try different things randomly. It's a brute force search. There is no better way of doing it.
So the next question there is, so one server could always be smarter than others due to its programmer. How does that solve the problem?
Absolutely. So the thing is that either because a server implemented an algorithm more efficiently or more accurately, more often, just because one guy bought a much bigger server, and that is why they are able to do many more iterations than others, they have higher chances of being picked as the random server. So they have more power in the system. And the only solution to this is open competition, which is that once people realize that this one guy in Surat has bought 100 servers and is hogging all of the mining rewards, then suddenly somebody in China sets it up, then somebody in Washington sets up a server, and it's an arms race. And that is why we have ended up with a situation where the Bitcoin network uses more electricity than Denmark. Okay? Yeah, go ahead.
Yeah, the question I think just got answered, but I'll just confirm. Everyone does the same computation. Doesn't the fastest computer win every time? I think you just said yes,
okay. So,
right?
Okay, just see, everyone is not doing the same computation. Everyone is running the same algorithm on slightly different inputs, right? And why is the input different? The block is the same. Okay, the transactions are the same, but the random text at the bottom is different. Okay, and they are not going through the random text in order 001, 002, 003. They are trying random combinations of the random text, and the first one to find something which matches the requirement wins, right? So it is not that everybody is doing the same computation. Think of it as a search space. Everybody is trying different lottery tickets, and the first one to find the winning numbers becomes the master, right? The point is that if you have a faster computer, you will try out more lottery numbers, so your chances of winning increase. But the fastest computer isn't going to win always. It's just your probability increases by a little bit. So if you have 5% of the all the computing power in the network, and I have 2%, then you are 2.5 times more likely to find the winning hash than I have. Does that answer the question?
Naveen, there is one more question, if you can take that one. Is the problem always about computing the hash, or can there be any other random problem?
Yes. So designing the problem is one of the areas of research. Trying this problem is the problem that is used for Bitcoin and Ethereum and a few others, but people are trying to find other ways of doing this. We will cover that in a later session. Another question here is, can we use cloud computing for this? In theory, yes, right? But in reality, most cloud computing platforms, so Azure, AWS, etc., have terms of service which say that you cannot use Bitcoin. You cannot use their facilities for mining, because it's really, really intensive for electricity. Okay.
Just
What
one
is?
quick question.
Yeah, go ahead.
This is by Abhay. The previous one was by Matin. This one is, so going back to earlier question, is it possible that no one finds the winning hash?
No, the thing is that, see, in theory it is possible, but the problem space is always such that, roughly, given all the number of servers which are all searching at the same time, it should take 10 minutes to solve it, right? Now, if it happens that for whatever reason, maybe the servers have become slow or number of servers have reduced, if it takes time, it's taking more than 10 minutes, maybe it's taking 20 minutes, 25 minutes, then automatically the system reduces the number of zeros required, which will bring the time down to half. So the difficulty of the problem, which is number of zeros needed at the end of the hash, that keeps adjusting based on the number of servers and the computing power in the system, so that it's always 10 minutes. So instead of 10 minutes, it can take 12, it can take 15. There's a really low probability that it can go up to 20, but not finding anything in more than that much time is extremely improbable. Yeah. So the question is, who defines the requirement, the target hash value, which is that basically how many zeros should your hash value end in? Who decides that? And that is baked into the protocol. It's a decentralized decision which is taken as follows. Every week, every 2 weeks actually, every server independently on their own, they look at the blocks that were mined in the last 2 weeks, right? There will be a few hundred blocks. Now you look at the time taken for finding the next block at each time, right? You can, just by looking at the timestamps, you can figure out the average time taken for mining each block in the last 2 weeks. If that is more than 20, then reduce the number of zeros. If that number is less than 5, then increase the number of zeros by 1. Okay. Note that when I say number of zeros, I'm talking about bits. And if I increase the number of zeros by 1, the search space doubles. Now it becomes twice as difficult for me to find a matching hash. So if it was taking me 4.5 minutes, it will now take 9 minutes. And if I reduce the number of zeros by 1, the time taken will become half. And again, notice that the way to decide how many zeros we are going for is purely based on all the previous blocks in the last 2 weeks. All the servers are seeing the same blocks. We have kept them in sync, right? So all of them do this computation independently, and they end up with the correct number, even though they are not coordinating with each other. Okay. Any other question related to the hash? All right, guys, we are almost at the end of blockchain. What I'm going to do is, there was a question, what is the incentive for you to be a master? I'm not going to cover that in detail today, but basically, there is a reward. Okay, in the Bitcoin network, you actually get new Bitcoins for being the master, but also individual transactions are giving commissions, and those commissions go to the master. So there is a lot of incentive. You get right now in Bitcoin, you get 12.5 Bitcoin when you become the master. So that's a huge incentive, but we won't go for that in detail. What I want to do now is, I know we are over time. I'm just going to take a few more minutes to talk about how conflicts are handled, and then some people can leave while I continue to answer questions. Okay. So basically, now I'm just showing you the situation on any one server, right? There is a chain of blocks with backward chaining. And now let us say what happens is that for some reason, two different servers at roughly the same time managed to solve the mining question at the same time. And they created two different blocks with slight differences in transactions. Okay. Now the thing is that you have to have identical blocks. You have to have identical database. So this situation that you are seeing on the screen right now is not sustainable. Okay. One server has created block 44A. Another server has created block 44B. Both of them are valid. Okay. But still, you have to pick one, and the other one has to be thrown away. And the rule for all servers is that if ever you see multiple blocks, I mean, you basically see any conflict in the chain, you're seeing multiple versions of the chain, what you have to do is you have to pick the longest chain and extend that. Or if two chains of the same length, then roughly pick one randomly and extend it. Okay. Now the thing is that here, whenever servers see this situation, they are going to start working on the next block. In that, they have to embed an ID of the previous block, and then they have to try to solve that hashing problem, right? So at this point, they have to pick which one are they going to extend. Are they going to put a block under 44A or 44B? And what happens is that randomly some servers might end up trying to extend 44A, some servers are trying to extend 44B, right? Because while you're doing your hashing, while you're trying to solve the hashing problem, you have already picked a block because you embedded the block ID. So here I've shown the situation where some servers are working on this, some are working on that. One of them wins. Okay, it created this block 45, which changed to block 44B, which changed backwards, right? Now, as soon as block 45 is sent to all the servers, now block 45, the chain going all the way up to block 45 is longer than the chain which is going up to block 44A. So what happens is that all the servers are going to say, okay, the second chain won, I'm going to delete 44A. And from this point on, all servers are now trying to create block 46. And for that, they will be trying to extend block 45. Okay. And remember that the problem is a difficult problem which takes roughly 10 minutes to solve across 100,000 servers. So the chances of two servers both finding a block at roughly the same time are very low. But this happening two times in a row is even more difficult, right? So let me just go through the quick situation like this. Two different servers found two different blocks, and they got extended by two other servers, and again even that happened at the same time. Now this is an extremely rare situation, but let us just assume this happens. At some point, the third extension is going to happen, and then this becomes the longest chain. Everybody will realize that they are supposed to delete the shorter chain, and now from this point on, everybody will start extending block 46B. So this ensures that, for say 10 minutes or 20 minutes, you might be in a situation where there is confusion. You don't know which one is really the winner. But after 2 or 3 blocks, situation will always normalize. It never extends for too long. Okay.
Naveen, there is a quick question here.
Go ahead.
Yeah. How does one become a server and get added to the network? Is there a criteria for this? This is Matin's question.
Yeah. So there is really no criteria. Okay. The whole point of blockchain is that we don't want authority. So anybody, the code for the blockchain, for most blockchains, the code is open source. you can just download the code and you start running it on your server, and that server will figure out some way to contact the nearest server, get connected to the network, and you're done. Right? So anybody can be a server, and all you need to do is run the code. All right, any other questions? Okay, let me just then go back to, hold on. Okay, there is a question coming up. I will come back to that question. Let me just see what I have. Just a quick some thoughts about conflicts. So temporary conflicts are possible, but over time, this will happen. I didn't cover digital signatures, how they work, but today we have run out of time. So maybe in a future session, I will cover that. Okay. Just I'm going to leave you with what is the future timeline roughly, and maybe in this we can add some sessions or change things around. Let's see if what questions we have. All right, this is good then. So far I'm not hearing any questions, but if you have questions, please ask. I'm happy to stick around here and answer the questions. But so far I have mainly talked about only blockchain. I didn't get into cryptocurrency and Bitcoin, and there's a whole bunch of new stuff related to that that will get covered in the next session.
Okay, Naveen, there is a question by Abhay. Yeah, it is, what is the incentive to become AV server? I don't have computing power or will never become the master.
Okay, see, if you don't have computing power and you are not going to become the master, then you really don't have a incentive to become a server, right? The thing though is that if you're a server, there is always a small chance. But if you have a really tiny server, then chances are low, right? People have come up with a clever solution to that. What they do is they create a pool of servers. Let's say 100 people get together, all of them have weak servers, so by themselves they don't stand a chance. But what they do is that all of them, they work together and they coordinate to solve the hashing problem. That each one says that you search for hashes like this, you search for this, you search for this, and any one of us finds it, we will share the rewards equally. This is called a mining pool, and that works very well. And in fact, a lot of the mining that happens in the world today is through mining pools. So even if there are 100 servers and you got picked only 3 times, right? So your chances of getting a reward individually would have been like only 3%. But because you have agreed to share the rewards, all 100 get the rewards from all 3 of those payouts. Okay. Question is, does this mean that the server has to keep track of each block? For example, if you are on 44A and I need to keep track of 44B and switch to that if it becomes longer. Yes, you have to keep track of all the blocks in the system. The thing is that whenever, let's look at 44A and B, right? Sorry. Now at this point, right, block number 44A was created by some server and block 44B was created by some other server. Both of them forwarded these blocks throughout the network. So yes, you would have received both the blocks, you would then choose that I am going to start working on 44A, but you have to keep 44B around because you don't know whether 44A is going to win or 44B is going to win. In case for some reason you didn't get 44B at all, right? A little while later, when say 46B gets created, at that time you will realize that you are missing some blocks, and then you can contact others and say, okay, I am missing a block, please give me so and so block. All right, any other questions? Another question is that if a chain becomes longer, does it slow down the process? The answer is sort of yes. In theory, every time you add a block, every transaction you add into the system, you have to go all the way back into history to check who was the last owner of this particular thing, right? So from that point of view, you have to keep the entire chain around, and you have to index it and so on. So yes, but the point is that at the end of the day, we are still talking a few hundred megabytes, right? No, not 100 megabytes, maybe some gigabytes. That's a small amount compared to the amount of computing energy that is going into the mining. So all of the issues about, worrying about the length of the chain and the memory it will take and all of that is not a problem, because the mining is a much bigger energy hog in any case, right?
So Naveen, I have a question. Hello.
Yeah. All right. By the way, let me just announce that at this point, we can consider this talk done. People who want to leave can leave. Now I'm just going to stick around answering any questions. I'll do it online while I get online questions, and then later I can answer them offline on the YouTube comments or on WhatsApp. Yeah. Bhushan. Bhushan, you're muted if you are talking right now.
Yes, we'll see you soon.
Okay. Okay, so one question is, how are bugs in server code addressed? That's a serious problem, because what happens typically, I mean, once there is server code, most people will just download the same server code and run it, right? Although that is not necessary. If a different server code, somebody else writes code completely differently, but it sticks to the same protocol, that is allowed. But in any case, if there is a bug, everybody is going to be running the code with the bug, and that can cause problems. In fact, there was a situation where there was a bug and a hacker exploited the bug to be able to steal some money or do some double spends. I think that situation lasted for about a couple of days or something like that. At that time, the protocol itself is of no help. Then what you have to do is that somebody points out the bug, maybe on email or on some website. They write code which fixes the bug, and then it tells everybody, please, there is this new version of the server, and please download that as soon as possible, otherwise there is a bug going on. Okay, that's part one of the solution. The more serious part is that while the bug existed, some bad things happened, right? Double spends happened, you have invalid transactions maybe in the chain, and now the community decide what to do about it. Bhushan, you need to go back on mute. Okay, community as a whole needs to decide what to do about it, right? So once in a while, what the community decides is that we are going to invalidate all the transactions until after last Thursday 12 noon, and then we are going to restart afresh, right? Now this only works if most of the servers agree to this. So what somebody will do is somebody will upload new code to the server software, which was something that deletes all transactions from until Thursday afternoon, and start extending the blockchain from that point on. And this will only work if all the servers agree to this, or at least a majority of the servers, right? Now, most of the time, if it is an obvious bug, there is no problem with servers updating it. They understand it and they accept it. Once in a while, what happens is that people say, no, no, no. The whole point of Bitcoin, the whole point of doing a blockchain is that we don't want a central authority and we don't want to wipe out the history. So we can't allow this no matter how bad the situation, right? That happened in Ethereum once. A really bad bug caused like, tens of millions of dollars to be stolen. And the main Ethereum guys decided to roll back the transactions, but other people said, no, we can't do that. And then the ones who agreed to the change, they became Ethereum, and the ones who didn't agree to the change, they became something called Ethereum Classic, and the whole network split into two parts, which are now not talking to each other. And the first one, Ethereum Classic, has like I think 100 billion plus market cap. Sorry, the first one, Ethereum, and Ethereum Classic has like 3 billion market cap. So that happens. Typically, how many transactions in a block? Is there an upper limit, right? That really depends on the blockchain implementation. In Bitcoin, there is an upper limit on the size of the block. So a block can be 1 megabyte only, and a transaction is usually around 200, 300 bytes. But depending on what the transaction is doing, the number of bytes of a transaction can vary. So that is why the maximum number of transactions in a block can vary, but it is 1 megabyte. Now the thing is that roughly gives you around a few hundred transaction at most, and lots of people were complaining that this is nowhere enough for something like Bitcoin, right? So, but the problem is that just increasing the block size from 1 MB to say 8 MB, or making it variable, some people feel that that is okay, other people feel that that's a security problem, right? So again, what happened was that this argument went on for like almost 2 years or something like that, and finally the whole Bitcoin split into two chains. Once, people who agree that we can increase the block size, and people who don't agree that we can increase the block size. And that's how you ended up with Bitcoin and Bitcoin Cash, two different networks, both of which are worth quite a lot right now. The question is, will efficiency, energy consumption of the blockchain determine its applicability? Now, this is in itself a big topic, so we will cover it in more detail at a later date. But the quick answer is that yes, energy, how much energy the blockchain is consuming determines how much incentive the servers need for doing all the mining, which determines how much commission you end up paying on each transaction. So the transaction fees for Bitcoin have been going up to a point where I think it is like $8 to $10 now, or maybe more, and that automatically some of the original use cases for Bitcoin that were envisaged are no longer possible. So yes, the energy consumption definitely affects what all it can be used for, but lots of people are working on alternatives which will reduce the energy consumption, and some of those we will be covering in later sessions. Any other questions?
I have one question, Naveen. Completely
Yeah.
non-technical one. So theoretically, is it possible that you put up a server, you spend all that energy, and
Yeah.
actually it comes to nothing, like a lottery ticket that you bought and it turned out to be a dud?
Uh, Yes. So see, I mean, basically, you buy a server and you start mining, and you were never able to find a block. That does happen. I'm sure that has happened to many people. So, whether you should be in the mining business is a tricky question, right? I mean, there is lots of competition. There are people in China who are running big mining farms. They can afford to do that because they don't have to pay the electricity bills, or they can just use bribery. There are people in Washington who get cheap electricity because of water source and cold temperature, so heating is not a problem, and so on. And it has been changing over the years. Every once in a while you find someone spent a lot of money in hardware, and that is now no longer good enough for getting rewards. All right, thank you everybody. I can continue answering any questions offline, but for now we will stop this broadcast. Right now there is no time decided for the future sessions. We will coordinate that, figure something out, and let you know. Next one will be on Bitcoin and other alternative currencies, why they exist and how they work. All right, thank you everybody.